Alright, this first video will be about units and dimensions, and we see this for regular physics 1-3. First off, base units. Length is the meter. Time is seconds. Mass is in kilograms. Now, one thing to understand, mass and weight are entirely different things. Mass is how much stuff, I think we use the term matter to describe that stuff in an object. Weight, though, is how much gravity acts on the mass. So your mass is constant unless you chop something off. Weight, on the other hand, is based entirely on gravity, so your location. So talking about some base distances, and you can read through this. This is also in your text. It goes all the way down from the size of a cell, like a red blood cell or a hydrogen atom, to the distance from Earth to Andromeda. And you can see these distances can be really big or they can be really small, looking at base 10s. Typical masses. Again, you know, we got really, really low masses like the mass of an electron, and then you got things really big like the mass of the Earth, which is something that's kind of important when we talk about gravity. Time spans. How old the Earth is in seconds, 10 to the 17th power. Well, we look at human reaction time, 1/10 of a second. How many seconds in a year, and so forth. This is, again, look at the exponents here to help us determine the different sizes. Now, prefixes are used to modify the base units, and we want to talk about the metric staircase. And so this is a kind of a modified staircase from what you saw in chem. You can see our different units, right? We got giga here, and we have giga, and then you go all the way down here to nano. And each stair step, as you can read from this, is a way of showing, or a 10 of a step. And so we can use that to find distances or make comparisons in the metric system. We will use this, and this is also on the in your project briefcase. I'll put it on the agenda also, but you can always access this if need be. So again, you can always look at the metric staircase to do your conversions. So let's get an example here. We look at E. coli has a length of 0.005 millimeters. We want to convert millimeters to meters. So we go right down first off what we're given, the 0.005 millimeters, and we want to find a conversion factor to go from millimeters to meters. To do that, we look at our stair steps, and just to kind of draw a modified stair step here, we got milli here. Ooh, too fast. We got milli here, centa, and then we got meters, or base unit. So we want to go from milli to meters. So we go 1, 2, 3 stair steps to get there. So with millis, we go 1, 2, 3, with a 1 in front. Each 0 is a stair step, and then put the 1 with meters. So we're taking 0.005 divided by 1,000, which will, as you see, turn out to be 0.123.125 meters. And that's the length in meters of E. coli bacteria. Let's look at another one. We got a warehouse that's 1,980 centimeters long, 1,050 centimeters wide, and 495 centimeters high. What is the volume? Volume is length times width times height. So we take our length of 1,980, we multiply it by our width of 1,050 and by 495. We punch those numbers into our calculator, and we get an extremely large number, 29,105,000. Now this is all in centimeters, so we'll go centimeters cubed. Now we want to go from centimeters cubed to meter cubed. Again, looking at our stair step, milli, centa, deci, meters. So meters is here. Here is centa. I want to go up 2 stair steps. So it's 100 centimeters. Each stair step's a 0 to 1 meter. Now, because it's cubed, the math isn't a whole lot different. I just cubed this and this. I cubed the units and the number. Units and the number. Centimeters cubed cancel, and so I'm taking that number, this 1 million number, and I'm dividing it by 100 cubed. And what I get is 1029.1 meters cubed. Again, we're not rounding the sig figs yet, but that's how you get the answer. So again, if you cube one part of the conversion factor, you cube everything. Blood in the human aorta can attain a speed of 35 centimeters per second. How fast is this in kilometers per hour? So I go 35.0 centimeters per second, and I want to go to kilometers per hour. So now I'm going to do, again, a conversion here. I'm going to go from centimeters to kilometers. So centa, deci, meters, and 1, 2, kilo. So centa to kilo, 1, 2, 3, 4, 5. So there's 1 with 1, 2, 3, 4, 5, 100,000 centimeters in 1 kilometer. And then I do my seconds to hours. There's 60 seconds in 1 minute. And there's 60 minutes in 1 hour. And everything will cancel out. And centimeters and seconds are gone, minutes are gone. We get kilometers per hour for my final answer. So with my calculator, it's a matter of multiplying across the top. So I take 35 multiplied by 60, multiplied by 60, and then I divide that answer by 100,000. And I get 1.26 kilometers per hour. Again, dimensional analysis, all things that we did last year. Please make sure you get and do the metric practice problems. This will help you. It's on mastering. Ask for help if you need them, and we'll get you through.